Hey, welcome to CPM 2. This is Module 4, Lesson 4. This lesson is over ratios and proportions. So, first we need to just be able to write ratios as a fraction. So, our first definition is a ratio. And it says a ratio is a quotient of two numbers or two quantities. A ratio, in fact, that should say is no different from a fraction, except that a ratio is sometimes written in other notations than fractional notation. So, you have a definition again of ratio. This is straight from your book. And you have three different examples of how we can write a ratio. You can say A to B. So if I'm using 1 and 2, that'd be like 1 to 2. You can use this colon notation. So 1 colon 2, and that still reads 1, 2, 2. Or our commonly used one fraction notation, 1 over 2, which is still 1 to 2. Okay, so you have fraction notation and colon notation. Now, unless it tells you how to write it, any of these three ways are okay. But in both of our examples, it is going to tell us to use fractional notation, so I do need to use this one here. But if it doesn't say, any of those three are acceptable. So example 1, write a ratio of each phrase. Use fractional notation. A says 2 parts salt to 5 parts water. So because it is 2 to 5, we'll do 2 over 5. B, a ratio of 3 parts to 6 parts, 3 parts oil to 6 parts gasoline. So we've got 3 over 6. Notice here, we can reduce this. So we need to divide both of these by 3. So my final answer here is going to be 1/2. You need to always reduce if possible. Okay, notice my instructions don't say write it as the simplest ratio, right? That's from now on, anytime you're dealing with fractions ever from this point, this is always the rule. If you can reduce them, you need to. Now, here, for example 2, I have this little helpful hint that says, whenever possible, we will convert quantities in a ratio to the same unit of measure. So, for example, on 2A, the ratio of 18 inches to 2 feet. Well, notice you got two different units. One is inches and one is feet. So, it's going to be easiest to turn our feet into inches. So, how many feet are in, or how many inches are in a foot? That's going to be 12. So we need to do 2 times 12. So 2 feet equals 24 inches. So now write your ratio. We've got 18 to 2 feet, so 18 inches. 18 over our 2 feet, but our 2 feet equals 24 inches. So now I have inches over inches, which is what I want. I need the same unit. Reduce if possible, and we can reduce. So let's divide both of these by 6. And my final answer will be 3 over 4. Okay, same thing here. The ratio of 40 minutes to 3 hours. Well, let's convert this. So we'll do 3 times how many minutes are in an hour. That's going to be 60. So this right here equals 180 minutes. So we'll do 40 minutes, so 40 on top, over 180. And we can divide both of these by 20. So I'll get 2 over 9. Alright, let's turn that page. Next one here says, if a ratio compares two decimal numbers, we will write the simplified ratio as a ratio of whole numbers. So I need to write a ratio in fractional notation in lowest terms. So here, I want these to only be whole numbers. So notice here, to get this 6.7 to a whole number, you're basically multiplying by 10. When you multiply by 10, that just takes this decimal and moves it one time over. Okay, moves it this way. Thing is, I can't just move that decimal and leave this one where it is. So if I'm moving that decimal once to the right to make it into a whole number, to make that into a 67, then I've got to do the same thing to the bottom. So your decimal's in the back, if you don't see it. So I'm going to move it one time over and put a 0 as a placeholder. So that's going to become over 100. Now, can I reduce? Well, 67 is a prime number, so no, I cannot. But if you can reduce, you need to reduce. Now, B, you've got two different decimals here. On this top one for that 2.5, all you need to do on that one is move it one time to get a whole number. But how many times do you need to move that decimal on that 3.15 to make it into a whole number? On that one, you've got to move it twice, right? You're taking this decimal and you're moving it 2 times to make that into a 315. So if I'm moving the bottom one 2 times, then I've got to move this top one 2 times as well. So it doesn't become 25, it becomes 250. Okay, so you've got to move all of them the same amount. If you've got to move one of them 2 times, you've got to move them both 2 times. So let's reduce. They end in a 5 and a 0, so I know I can divide these at least by 5. So 250 divided by 5 gives me 50. And 315 divided by 5 gives me 63. And I want to say that's as simple as that can go. Yes. Okay, so reduce in when and if you can. All right, so that's our section on ratios. I think the rest of this lesson, yes, the rest of this lesson is going to be over ratios, or is going to be over proportions. So objective B, we're going to solve proportions. So our definition here is a proportion. It says ratios can be used to form proportions. A proportion is a mathematical statement that 2 ratios are equal. So for example, we've actually been dealing with proportions before. If I have something like, well, let's just take that one we had on the front. When I had 3/6, we reduced this to 1/2. This right here is a proportion. If you put in your calculator 3 divided by 6, you get 0.5. And if you put 1 divided by 2 in your calculator, you also get 0.5. So that's what it means by proportion as a mathematical statement that 2 ratios are equal. Basically means we have equivalent fractions. Okay. So right here, to solve proportions, we're going to use cross products. It says if AB equals CD, then AD, you're just multiplying those together, AD here equals BC. You're cross multiplying. When you have this equal sign in the middle, you're not multiplying straight across. So for example, if I had a fraction 1/2 times 3/6, when you have this times in the middle, you multiply straight across, right? So 1 times 3 is 3. 2 times 6 is 12, and then you reduce. Okay, but now I don't have that times in the middle. Now we're going to have something like 1/2 equals these two here. Okay, so it means that they're equal with each other. And we can even use that on our proportion that we have right now. If you cross multiply here, you get 3 times 2 equals 1 times 6 Are those equal? Yeah, 3 times 2 is 6, 1 times 6 is 6. Okay, so they're equal when you multiply diagonally. So that's how we're going to go about solving these on example 4. It says solve for x. Now, it does not matter which way you cross multiply first. You can cross multiply this way first, but I'm going to go this way first. I like to cross multiply with that x. So x times 5 is 5x. Cross multiply the other way. 45 times 7, use your calculator. We get 315. Now solve for x. So divide by 5, and this equals 63. Okay. Biggest mistake I see with these is when you cross multiply, you've got to make sure you set these equal to each other. A lot of times you guys will do something crazy like 5x over 315. Okay, it doesn't become a fraction, it becomes an equation. So same thing here. On A, I cross multiplied this way first, right? But on this one, let's cross multiply this way first. It doesn't matter. I just always like to pick up my x first. So I get 3x equals, cross multiply the other way, 8 times 63. That's going to give me a 504. Okay, now it's a one-step problem. Divide both sides by 3. And I'm going to get 168. Okay, let's flip the page. We got 2 more examples of solving proportions. So same thing, cross multiply where you get that x first. So I'm going to go this way. So 4x times 2 gives me 8x. And then 6 times 7, cross multiply the other way. Gives me 42. Okay, now divide both sides by your 8. And this one, we get 5.25. Okay, same thing here on D. I'm going to cross multiply this way first to get that x, but it does not matter. So 4x times 6 gives me 24x. 9 times 2 gives me 18. Get x by itself, so divide both sides by 24. And we get x equals 0.75. So on these 2 problems, notice we both got decimals. That's okay. Decimals are not your enemy. Okay. So now that we know how to solve proportions, now we need to write our own proportions and solve problems. So it says right here, writing proportions are a powerful tool for solving problems in almost every field, including business, chemistry, biology, health science, and engineering, as well as in daily something. I don't know what that word was supposed to be. My bad. Maybe daily life? Let's go with the life there. Okay. Given a specific ratio or rate of 2 quantities, a proportion can be used to determine unknown quantities. So, what is confusing about these is like example 5, 6, and 7. There are literally 4 different ways to write this. And there are 4 different ways to write this correctly, I should say. More than 4 ways to write it. But there's 4 ways to write it correctly. So, I'm going to show you a couple different ways here. You just got to make sure that you follow your own pattern. Follow your pattern. Okay, so here's what I mean by that. Example 5 says on the Chamber of Commerce map, of Abita Springs. 5 miles corresponds to 2 inches. How many miles correspond to 7 inches? Okay. So, if I use this 5:2 as my first fractional ratio, 5 miles to 2 inches. Okay, and actually with this, I don't need units like I did with dimensional analysis as much. So I'm going to kind of put these in parentheses because I'm not needing them. Okay, as far as like the solving the problem portion. What I do need those units for is to make sure that I set up this one here in the same manner. So what I mean by that is, unlike dimensional analysis where you want like miles on top, so that means miles goes on bottom, you want these to be the same. So if I did miles on top, I need miles on top over here, and then inches on bottom over here. It needs to follow the same pattern. So then my other number that we were given was 7 inches. So this 7 goes down here. And then it wants to know how many miles. That's your x. That's what you're solving for. Okay. So I'm going to rewrite this over here with just the numbers because I don't need those units. So now cross multiply. If I go this way, we've got 2x equals 5 times 7 gives me 35. Divide by 2, and we get x equals 17.5. But 17.5 what? What did we just solve for? Miles right here. X miles. So 17.5 miles. And you do need your unit in your answer. Okay, so I said I would show you another way to do this. And I'm going to end up erasing this. Okay, so you might not want to write it because I'm going to erase it. But let's say I did inches to inches, right? Let's say I did 2 inches to 7 inches. Okay, what did this 2 go with? That went with the 5. So then I do 5 miles. And then how many miles? My x goes with that 7. So then you do 7 miles. If you notice, when you cross multiply, you're still doing 2 times x and 7 times 5 the same way that we did right here. So it's still a correct proportion. Okay, we could have also switched this up. And instead of doing 5 over 2, I could have done 2 over 5. So I could have done 2 inches over 5 miles. So then I would have had to do 7 inches on the top over how many miles? My x miles. Again, I'm still doing 2 times x and 5 times 7. Okay, so what I'm trying to get at here is that it does not matter how you set up this first proportion here, but however you set this first one up, you've got to follow your own pattern and write the second one in the same exact manner. Okay, all right. So now after I've probably confused you, let's try again. Example 6. The standard dose of antibiotics is 4 cc, which stands for cubic centimeters, for every 25 pounds of body weight. At the rate, find the standard dose of a 140-pound woman. So, if I go with my first, the first thing they gave me 4 cc's for every 25 pounds. So that's going to be my first ratio. So 4, I'm going to put this in parentheses again, cc to every 25 lbs. So because I did cc on top and lb on the bottom, that means I need cc on the top and lb on the bottom, right? These units need to match each other. So the other thing they give me is a 140-pound woman, so that needs to go down here with my pounds. So we are finding at what rate we're finding the standard dose. Okay, so cross multiply. So when you cross multiply, I put those parentheses, those units in parentheses. I don't care about those, okay? So I'm just doing X times 25, okay, and that equals 4 times 140. We get 560. Divide both sides by 25. And we get X equals 22.4. So I need 22.4 what? Well, my X went right here with that CC. So 24 CC, or 22.4 CC. Okay, last one. A 16-ounce grande non-fat skinny mocha at Starbucks has 140 calories. So that's my first proportion right there. We have 16 ounces and 140 calories. So how many calories are there in a 12 ounce? So I want my ounces up here. So my 12 goes here. How many calories? I'm finding my X calories here. Ounces over calories, ounces over calories. So cross multiply. This time I'm going to go this way first so I can get that X. So 16X equals 12 times 140. It's going to give me 1680. Divide by 16. And we get X equals 105. Okay, and 105 what? What did we solve for? We have X calories. So 105 calories. Okay, so just make sure you follow your pattern. However you set up that first ratio, set up the second one the same way. And then lastly here for unit rates. Okay, it says right here, a rate is a ratio that is used to compare different kinds of quantities. So a unit rate describes how many units of the first type of quantity corresponds with 1 unit of the second type of quantity. Some common unit rates are miles or kilometers per hour. That means 1 hour. Cost per item. Earnings per week, etc. So, to write a rate as a unit rate, you are going to simply divide the numerator by the denominator. Okay, so for example here, write the rate as a unit rate. So we have 448 calories in a 4-ounce serving. Just keep this in order. We have 448. Let's go ahead and put those units on here. Calories in a 4-ounce serving. So I am basically wanting to know how many calories are in just 1 ounce. So just divide in your calculator. 448 divided by 4 gets me to 112. So I have 112 calories per ounce. Okay, same thing here. You have 296 riders and 4 subway cars. So I've got 296 riders over 4 subway cars. And again, I'm wanting to know how many do I have in just 1 subway car. So divide. 296 divided by 4 gives me 74. So that means I have 74 riders per 1 subway cart. So 74 riders / subway. Okay. So let's kind of use this as a word problem now. It says a hummingbird moves its wings at a rate of 3,000 beats a minute. Write this rate in wing beats per second. So take our first one here. We have 3,000 wing beats. And it says in a minute, so in a single minute. Okay. I'm wanting to write this in what unit though? In seconds. So, what that means is I need to convert my minutes here into seconds. So, how many seconds are in 1 minute? 60. And now I can divide. So 3,000 divided by 60 gives me 50. So that means I have 50 wing beats per second. Okay, in example 9, we got a part A, B, and C here, and little hint for you. You're going to have a test question that's very similar to this. It says one student drove 440 miles in his car on 15.5 gallons of gasoline. His sister drove 240 miles in her truck on 7.25 gallons of gasoline. So A says find the unit rate of the car. So here's my car. And my car went 440 miles in 15.5 gallons. So just divide. What is 440 divided by 15.5? Okay, you get a really ugly decimal. Let's go to 2 decimal places. Let's go to the hundredth. So I'm going to write that in here. We are going to round to the hundredth. So that becomes 28 point, if you type that in your calculator, you'll see it's 0.387. That 7 makes that 8 go up, so 0.39. B says find the unit rate of the truck. The truck went 240 miles per 725 gallons. So divide again. We get 0.25. Okay. So let's go to the nearest hundredth again. I'm going to get 33 point. That 3 makes that 0 stay, so that's actually just a 0.1. Okay. So which vehicle here gets better gas per mileage? Would you rather get this many miles per 1 gallon or this many miles per 1 gallon? Weirdly enough, I want that truck. Now, that's probably never going to happen in real life, but I want that truck. All right, that's all I've got for this lesson. Pause this video as you need to. Let me know if you guys have any questions. Have a good day, I guess. Not a guess. I want you to have a good day, but that got weird. Sorry. Bye.